Hello and welcome to today's problem, 1-to-1 best time to buy and sell stock. So you're given an array prices where prices at a given index is the price of a given stock on the ith day. You want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell it. And at the very end, we want to return the maximum profit you can receive from the transaction. If you can't achieve any profit, then you want to return 0. So you're given two examples here. For the first one, you have a list of numbers and you want the output to be 5 because on day 2, where the price is 1, you can buy, and on day 5, where the price is 6, you can sell, equaling a total profit of 5, which we can then return as the output. With example 2, since every single number is decreasing, no transactions are done because you can't buy on a given day and sell for a profit. And the constraints we have over here, okay, so that makes sense. So no negative numbers. Okay, so my thinking for what we can do here is we can basically traverse through a given number list, right? That's the first thing we have to do. So we'll go ahead and traverse it. While we're traversing through it, what we can do is we can keep track of what the lowest number at a given point is so far. So maybe we'll have a lowest, basically a lowest variable over here. And I guess we'll start off at the very first number because that's the first element we traverse through. So we'll have this set the prices at 0. Basically, what we can do as we keep going forward through the, basically through the list, and go here, we can keep track of what the lowest is through this variable, and then we can figure out what the potential profit could be at this specific number by subtracting the current price from the lowest. So we can have, let's say, like result, which is basically what we're going to return at the very end. And then from there, what we can do is figure out basically what the lowest is and the price to figure out whether or not we can use that as the new greatest profit. So okay, let's do this with an example here. We start off at 7 and we set that as the lowest price here, so that's 7. As we traverse forward, we encounter 1, which is the new lowest, so we'll have lowest equal to 1, and then eventually we encounter 5. And 5, because that's a higher price, we can then make a profit by buying on day 1, where that's the lowest one, and you can sell it on day 5, achieving an effective profit of 4. So we can set that, the price at the current index, minus the lowest, which is 1, to equal 4, and we can have that set as the current result until you find something better. So for this one, we'll go ahead and do the same thing. So 3 minus 1, that'll be 2. That is you do make a profit off of this, but the thing is, the result isn't the largest available. It isn't the maximum, so we keep the price the same. So we'll go the max of this. And then for this one, since you make a greater profit, 6 minus 1 is 5. That's what the result is going to end up being. So then you can turn that as the profit, and then you can keep traversing forward to 4, same thing. And at the very end, what you can do is return that final result. So yeah, just in short, we have a lowest variable keeping track of the lowest value we've encountered so far. We can choose that as the buy day. And then as we traverse through the array, we can keep track of what the maximum profit is by figuring out the price minus the lowest and then keeping tabs on what the maximum is and returning that as the final result. So the time complexity of this would be O of n because you're only traversing through the array once, and the space complexity of it would be O of 1 because you're not keeping any of the elements in the list basically stored in an array somewhere. All of these variables are O of 1. So I'll go ahead and code up the solution for this now. We'll have the lowest at a given point, which is just prices 0, and then we can have the result, which I guess the current profit will be 0. So we can then iterate through for I in range length prices. We can figure out whether or not prices at a given index is basically is the lowest by checking to see if prices I is less, or if it's less than the current lowest, then we can set that as the new lowest. After that, what we can do is we can keep tabs on what the maximum is by doing this: maximum of itself and the current price. And then as we traverse through, basically we'll keep tabs on what the lowest is, and we'll set that to it if we need be. And at the very end, we can go ahead and return the result. So yeah, just walking through this again, we want to check what the lowest, basically grab the lowest value, and as you traverse through it, keep replacing it as the lowest, and then you want to figure out whether or not the current price minus the lowest is the greatest as you traverse through the array. And at the very end, we can then return that as the result over here. So if we go ahead and run this really quickly now. Okay, accepted. Go ahead and submit. Okay, there you go. Thank you for watching.